Okay, into the second half of the paper then. First of all, it's a percentage question. Calculate 36% of £158. So what I've said to you is when you're working out a percentage of something, turn the percentage into a decimal by writing 36% as if you were writing 36 pence in pounds. So 36 pence in pounds you would write like that. So to find 36% of that, you would find 0.36 times 158. So £56.88. Part B. Cement mixer for hire, £16.99 for the first day, and then £6.25 for every day after that. Rian hires the cement mixer for a total cost of £48.24. For how many days did she hire the cement mixer? So that's what it comes to in total, and you know that the first day is going to cost that. So if I take that out of the total, then that's going to give me what is left for every day. So let's do that first of all. So daily rate will be £48.24 less £16.99, which is fixed for the first day. So £48.24 minus £16.99, £31.25. So for all the other days combined, it's going to come to £31.25. So if we divide £31.25 by that, that'll tell us how many additional days there's been. So additional days will be £31.25 divided by £6.25. So we got our £31.25, divide 6.25, 5 days. So there's 5 additional days plus the first day, 6 days altogether. So hired for 6 days. Okay, number 11 is a pie chart question. It gets us into the D grades, and we should be getting quite familiar with how to work these out now. So there are 90 families, so we have to share our 360 degrees of our pie between the 90 families. So they each get 360 divided by 90, 4 degrees. So every person in the survey gets 4 degrees of the pie. 5 families have no cars, so there's 5 lots of 4 degrees there, which is 20 degrees. Then 1 car will be 42 lots of 4 degrees, which is, just off the screen there, 168 degrees. 33 lots of 4 degrees, 132, and 10 lots of 4 degrees is 40. So that's all the calculating you need to do. Now you need to draw it. So start off with one line for your first slice. Get your protractor, center of the protractor on the center of the pie, line 0 up with the line that you've drawn. Now if I'm going in this direction, 10, 20, 30 is on the outside of the scale, so 20 degrees will be there. Mark a dot and then join the center to the circumference going through that dot. So that's 0 cars. Then get your protractor, move the 0 to the start of the next slice, and this one's going to be 168. Again, we're going around the outside of the scale. 160 is there, 170 is there, so 168 there, make a dot. That's 1 car. rotate your protractor around to the start of the next slice, which is 0. Here we're going to go around to 132. There's 130. There's 132. So that's 2 cars, and that's 3 or more cars. So that's 4 marks, nice easy 4 marks for your grade D. Okay, then we got our reading a table question. Let's see if I can fit this on the screen, just about. Okay, so let's take a look at the context of this. The following table is an extract from a coach timetable for coaches going from Swansea to Gatwick North and Gatwick South airport terminals. So here are the departure times. This is where it's travelling from. So it's going from Swansea, then to Port Talbot, then to Bridgend, and so on, finishing off in Gatwick South. And these are the times that they leave Swansea and get to Gatwick. So the first question, how many coaches arrive at Newport between 4 AM and 10 AM? Well, here's Newport, so these are the times of all the coaches arriving in Newport, and we want to know the ones that go between 4 AM and 10 AM. So that's 4:45, so that's 2 early. So that one, 5 to 8, 9 o'clock, and that one's too late, goes at 10:15. So those 3 are the 3 coaches that arrive at Newport between 4 in the morning and 10 in the morning. There are 3 coaches. Mary catches the 4:45 coach from Bridgend, so that's that one, to go to Gatwick South. How long should she be on the coach? So she's going from 4 in the morning, sorry, 4:45, and she gets there at 5 to 10. So 4:45, just count on your fingers, 4:45, 4:46, 4:47, 4:48, 4:49, 4:10 will be 5 hours. And then from 4:10 to 5 to 10 is another 10 minutes. Mr. and Mrs. Williams are booked on the 15:20 flight from Gatwick North. They catch the 7:25 from Cardiff, so they're on that bus there. How long will they have at the airport before their flight takes off? So that's the bus that they catch. That gets into Gatwick North at 5 to 12, and they are catching a 3:20 flight. So 5 to 12, 5 to 1, 5 to 2, 5 to 3 is 3 hours to 5 to 3, and then from 5 to 3 to 3:20 is going to be another 25 minutes. So 3 hours 25 minutes. So count on in hours, and then once you've got the full hours, work out in the minutes from there. Okay. Oh, there's another part. One of the coaches diverts to another town between Newport and Heathrow. Which coach is it, and explain how you know. Okay, so what we need to do here is look at the length of time that it's taken to go from Newport to Heathrow, and the one that is different is the one that's going to be the one with the diversion. And I can see straight away that this one is taking whole hours. It's going from 9 in the morning to 1 in the afternoon, so that's exactly so many hours, whereas each of the others is going from one set of minutes to another set of minutes. So the only one that's going exactly from 1 hour to another hour is the 9 o'clock from Newport. So which diverts to another town between Newport and Heathrow? It's the 9 o'clock. because it takes a different amount of time. Okay, question 13, volume question. Calculate the volume of a metal cuboid measuring 12 centimeters by 7 centimeters by 11 centimeters. So when you're working out the volume of a cuboid, you need to know that you're multiplying its length by its width by its height. So the volume of this is going to be 12 times 7 times 11. Which is 924. And the units that you would have for volume in this case would be cm, and cube would be volume. So we know that that volume is 924 centimeters cubed. The above metal cuboid is melted down and made into a different cuboid as shown below, with a base measuring 6 by 13. Calculate the height of this cuboid correct to 1 decimal place. Well, the way that we'd work out the volume is exactly the same. It would be 13 times 6 times h, and we know that this volume of this cuboid is the same as that one, because this was the one that was melted down to make this. So we know that that has to come to 924. So we've got an equation. We can work out what 13 times 6 is. It's 78. So 78 times h is 924. I want to get the h in its own, so I've got to undo a times 78. The opposite of times in 78 is divide by 78. So we do 924 divided by 78, and that's 11.8 centimeters. Okay, and you may think, oh, that doesn't sound right, but there's a clue in the question that it's correct to 1 decimal place, so you're not going to get an exact answer. 1 decimal place is the 8, but you look at the next digit beyond it. If that was 5 or more, it means that it would be closer to 11.8 than 11.9, but it's 4, which means it's closer to 11.8. Okay, this is one of these new investigative questions. So let's talk our way gently through this. Peter decides to cover the floor of a room with a striped carpet. The shop sells this striped carpet from a roll that is 3 meters wide at a price of £25 per meter length. This floor is rectangular in shape with a length 13 meters and breadth 8 meters. The carpet is laid to ensure that the stripes on the carpet are parallel to 2 of the sides and lie in one direction only. So we're either going to get the stripes all going that way, or we're going to get them all going across. Showing all your calculations, investigate ways of covering the floor and find the cost of the cheapest way of covering the floor. Right, well, I'll try and do this at the bottom here so that it's on the same page. So there are only 2 ways of covering the floor. You can either cover it with the stripes running vertically, up. But if the stripes are running up, because this is 3 meters in length, I'm going to need 4 lengths of carpet. Because if I had 3, I'd have 9 meters going along, which means I'd have a gap with no carpet. So I'm going to need 4 widths of carpet, and the length that I'd need then is 8 meters. So to cost that, it's 3 meters wide at a price of £25 per meter length. So I'm going to have 8 meter lengths, so it's going to be £25 times 8, and I want 4 of them. So So I'm going to need 4 lots of 8 times £25. So that's going to come to 4 times 8 times 25. It's going to cost him £800 if he wants the stripes going upwards. Now, if he wants the stripes running across, this time he's going to need 1, 2, 3 widths. 2 widths would only give him 6, so we'd have a gap. So he's going to need 3 widths. And this time the length would be 13 meters because it's going to roll that way. Okay, so our carpet now is going to have the stripes that way. So 3 widths of length 13 meters, and this will cost 3 times 13 times 25. 3 strips, and each strip is going to be 13 meters long, costing £25 a meter. So this time on our calculator we've got to do 3 lots of 13 lots of 25, £975. Okay, so it's going to cost him more if he wants his stripes going along the room. And what we were supposed to be doing is showing all our calculations, investigate ways of covering the floor, which we've done, and find the cost of the cheapest way of covering the floor. So stripes running up will be the cheapest. Okay, so that's what we need you to do. There's 8 marks for that, and the reason it was so many is because they're really relying on you to get your head around all the different possibilities that could happen there. And that's followed by another one of these ones that you have to think carefully about. At 11 AM a ship sets off from A and another ship sets off from B. Now when I first read this I couldn't see for the life of me where A and B were. Then I looked over the page and there's a diagram that goes with it. Okay, so that's the diagram that we're working with. So we've got a ship setting off from A, which is there, and another ship setting off from B, which is down there. The diagram has got a scale of 1 centimetre to 10 kilometres. Each ship travels in a straight line. The ship from A maintains an average speed of 30 kilometres per hour. So every hour it's travelled, it's 30 kilometres further away than it was in the previous hour. Whilst the ship from B keeps an average speed of 20 kilometres an hour. The ships meet at 3 PM. Giving full details of your working and reasoning, find the position where the 2 ships meet. Write down the bearing of this point from B. Well, let's not worry about the bearing for a minute. We can work out here that if they both start at 11 AM and they meet at 3, the ships have been travelling. Let's go back to here. Ships have been travelling from 11 to 3 in the afternoon, 4 hours. So ship A has travelled, okay, so what I said was 30 kilometers an hour. For every hour it's been moving, it's travelled 30 kilometers. So in 4 hours it will have travelled 4 lots of 30, 120 kilometers. And ship B has travelled, and that has also gone 4 hours, but at the speed of 20 kilometers an hour, so it wouldn't have travelled as far. It's only travelled 80 kilometers. Right, so we've got to work out now on our diagram where they have met. And we know that ship A has travelled 120 kilometers, so at that scale that means it's going to be 12 centimeters away from there, but we don't know which direction it's in, but we know that it's always going to be exactly 12 centimeters from that point. So that's going to be part of a circle which is going to have a radius of 12 centimeters. Okay, so we get our compass point on 0, open it out to 12 centimeters, which is about as far as this compass will open. Put the compass point on A and draw your arc. So anywhere on that curve is going to be 12 centimeters and therefore 120 kilometers away from point A. Now what we do is exactly the same thing for ship B. Ship B was traveling 80 kilometers, so we know that that's going to be 8 centimeters. So again, get your ruler, open it out this time to 8 centimeters. Okay, see, 8. Now put your compass point at B, and you know when we draw this arc, that anywhere on that part of the curve is going to be exactly 8 kilometers from B. Now where those two circles cross is going to be where the ships meet at 3 o'clock. But clearly they can't be in both places, okay? Because what this is saying is this point here is 120 kilometers from A, and it's also 80 kilometers from B. There's your 80 kilometers from B, there's your 120 from A. Similarly there, that point is also 120 from A and 80 from B. But it can't be in both places. So let's go back to the question now and see if there's any more information in there which will help us work out which of those two it's going to be. And what you will see is it says here each ship travels in a straight line. Well, if ship A is traveling in a straight line, it isn't going to get to there because there's that land there. Okay, so it can't cross land, so it's not here because ship A would have hit land. Okay, it would have hit land there. So therefore, that is where our ship is, or the ships. Ships meet here. So the last thing that we've got to do now is to give the bearing of this point from B. So here's B, so the bearing, remember, is measured clockwise from north. So I need to find that angle there. Bearings are measured clockwise from north, so your 0 on your protractor is vertically upwards. The centre of your protractor is at town B. And then you're measuring clockwise. On mine that's 18 degrees. So the bearing, that's 18 degrees. We write bearings as 3-figure bearings. So if there's only 2 digits in the angle, you put a 0 in front of it. so the bearing is 018 degrees. Let me talk you through that again. We can work out that the ships have both been travelling for 4 hours. They started at 11, they met at 3, that's 4 hours. They're travelling at an average speed, ship A, at 30 kilometers an hour. So in 1 hour it's gone 30 kilometers, 2 hours 60, 3 hours 90, 4 hours 120 kilometers. And ship B is travelling at a different speed, and we've worked out that that's travelled 80 kilometers. So on our diagram then, I know that 120 kilometers is going to be 12 centimeters because that's the scale. So I've got to find where 12 centimeters from A is. And because it's fixed, that's going to be a radius of a circle 12 centimeters. So that's that circle there. So I know that the ship is somewhere on that curve. Ship A is. The second ship is going to be 8 centimeters from B. So I do the same. I open my compass point on B, open it out 8 centimeters, draw an arc. Where the two curves cross is where the ship is, except here they cross in two places. So we have to go back to the question to look at how we can eliminate one of them. And because it says in the question that the ships travel in a straight line, it can't be here because that would have meant that the ship from A would have crossed that land there. That means it must be there. Once we've worked that out, what we then have to do is measure the bearing. So we draw the line from B to where the ship is, and then measure clockwise from north. North is 0, that measured 18 degrees, so the bearing is 018. So again, quite a bit of work you've got to do independently there. It's not step by step for you. Question 16 is an exchange rates question. A truck driver is travelling across Europe to drop off goods in Switzerland and in Italy. He will return to Switzerland on his way home to pick up another load before returning to the UK. Before leaving home in the UK, he exchanged some currency for the trip. So the exchange rates, £1 buys 109 euros and 166 Swiss francs. So for every pound you get 109 euros, so £2 you get 2 lots of that, and so on. The truck driver has been planning to buy a new camera. In Switzerland he sees the camera on sale for 70 Swiss francs. In Italy he sees the same camera on sale for 46.35 euros. Convert each of the prices to pounds, giving your answers to the nearest penny. So if we were going from pounds into euros, we'd be multiplying. So if we're going the other way, we have to do the opposite of multiplying, which is to divide. So the Swiss camera will be the 70 divided by, so in Switzerland is 166. So we do 70 divided by 166. Okay, and we need to give it to the nearest penny, so it's going to be 41, it's either going to be £42.16 or £42.17 to the nearest penny. That would be 2 decimal places. The next digit is 5 or more, so it's nearer to £42.17. Then we do the same for the Italian camera. Don't know where that N came. Italian camera. So for the Italian camera, it's going to be 46.35 divided by 109. Which is £42.52. Look at the third digit, it's less than 5, so it's £42.52. Should he buy the camera while he's in Italy or wait until he's travelling back through Switzerland? Give a reason for your answer. Well, he's going to buy it in Switzerland because it's cheaper. Not much cheaper, but nevertheless cheaper. Question 17. Okay, 17a. We've practiced lots of these. Nth term of a sequence, look for the difference to find the n rule. So this one you can see is going up in threes, so it's a 3n rule. Then you ask yourself, is the first term 3? No, it's 7. So in order to go from 3 to 7, I have to add another 4. So the rule is 3n add 4. B, rearranging formulae don't come up very often, but all you have to remember is you treat it as if you were solving an equation. The rules are the same. I need to get the n on its own. So the first thing I have to do is get rid of the take 32. The opposite of taking 32 is adding 32. So that means that the other side becomes m add 32 is 5n. Now I need to get rid of the 5. The 5 and the n are joined by a times. So the opposite of timesing by 5 is dividing by 5. And in algebra, divide by 5 we write as over 5. So that leaves the n on its own, and that's how we do it. So that's the end of that question. There's no simpler than that. Question C is quite a tricky one. In a sequence of 4 numbers, the difference between each number is 7. The sum of the 4 numbers is 6. What are the numbers in the sequence? So what that means is if we start with, let's say that the first number is 0, the next number will be 7, the next number will be 14, the next number will be 21. They are going up in 7s, okay, in this sequences, so they're going up in 7s. But if we add those 4 together, we're going to get 0 plus 7 plus 14 plus 21 is 42. We need a difference of 6. So in order for that to happen, I've really got to bring that number down. And for that to happen, these numbers are going to have some negative numbers in them. So let's start at minus 5, say. So if the first number is minus 5, and they're going up in 7s, the next number will be 2, the next number will be, hang on, I lost count, 5, 7, the next number will be 9, and the next number will be 16. Those are going up in 7s as well. So what does that come to? So if we got minus 5, add 2, add 9, add 16, we get 22. So that's better, but still quite a way off. We need more negative numbers. So I'm going to try minus 10. So if the first number is minus 10, the next number will be 7 higher than that, which is minus 3. Then the next number will be 7 higher than that, which will be 4. And the next number will be 7 higher than that, which will be 11. So let's add these up. So we're going to have minus 10. Now the minus button on the calculator is that one. So we're going to have minus 10 plus minus 3 plus 4 plus 11 equals 2. So that's got a difference of 2. I want a difference of 6. So a minus 10 has gone too far. So I'm going to try minus 9. So if the first number is minus 9, the next number is going to be 7 up from that, which is going to be minus 2. Then I'm going to have 5. Then I'm going to have 12. Minus 9 plus minus 2 plus 5 plus 12 equals 6. So those are my numbers. Minus 9, minus 2, 5 and 12. Okay, and finally an area question. Now In all the past papers we've looked at so far, I have flipped through to the second page and said we'll come back here if we need to. This time we need to, because the first thing that we have to do is work out the area of that trapezium. So the way the formula works is, what this is saying is A plus B are the two parallel sides. So you're going to add the two parallel sides together, times by H, which is 5, and half it. And you can type this into your calculator exactly as it's written there. So the area of trapezium, so if I call that A, area of A will be half, open bracket, 6 plus 8, close bracket, times H, which is 5. So on your calculator, use your fraction button if you like. There's your half, open bracket, 6 plus 8, close bracket, times 5 equals. So the area of that is 35 centimeters squared. Now, you're not given the area of a triangle formula. You need to know that the area of the triangle, or B as I've called it, is going to be half times base times height. Half base times height. You've got to know that, you've got to learn that. Well, half of 10 is 5. So that's 5x. But I know, because the question is telling me that these have got the same area. So 5x, the area of that, must equal 35. So if 5 lots of x equals 35, 1 lot of x will be 35 divided by 5, which is 7 centimeters. And that's it. So there were some quite different questions in that paper, but as I've said plenty of times in class, you've got 2 hours to do this paper, and most of the questions you've practiced so much that you can fly through them, but then slow down and think carefully about some of those trickier questions.